Alright, so the project at hand today is I want to do something about this rock that my bridge is sitting on. Alright, so this rock, it's been like this a long time. I kind of dug out this area here for the building to go here. And doing that now made the rock kind of look like it may be unstable. So before I put this bridge on here, I actually did dig back on top, and the rock does go back further into the cliff than it appears from here. This is right after I dug it off and cleaned off the top of it. You can see it comes back pretty far into the ledge. You know, the further this rock goes back into the cliff, the better I feel about it. And in this photo, you can see it's at least going back to this point here. And then this is probably the most helpful photo. I should have kept digging it off on the right side here to see how far it actually goes, but it does go further back than it looks from down below. This concrete I poured here does kind of pin it to the rock next to it. And there it is after the bridge footing is poured. Now, since the bridge is in place, all that's visible is this area here and this area here where it looks like it's an immediate problem. You know, standing here, it looks like it's about to fall. And looking at it from the other side here, it looks even worse. So I want to do something about this, because if that fell down, it would be probably a month worth of work fixing this stuff. So the plan is to just kind of get some big I-beams up against it just to support it. So I got some ones in here just to kind of show you what I want to do. All right, so before I do anything to it, let's get a log up against the thing so it seems secure, because I'm going to be digging and drilling into it and stuff. Alright, so that's just there as a temporary support, which it probably doesn't need, but I feel better about it. Putting this in here. Alright, I'm pretty happy with that. I actually put a bunch more shale right here too, just to lock that bottom in. Alright, so now here we're dug. This is solid bedrock right there. So that's a real good foundation for putting this beam on. Alright, so I want to put it right there. I kind of want to like shave some off that rock. Let me see how that goes. Alright, this is about how big of a plate I want to use. So it'd be nice if it was... Look at that. Alright, so this is about the size of my plate. That's pretty good. That's about the right angle too. That's the angle it's gonna be. I ain't changing it. Look at that. That's like perfectly smooth too. That's cool. Check out this cool magnet. So you put it on there, flip this, and then it's stuck. That's the electric magnet that makes this thing stick on here. These bits are more hole saws than they are drill bits. Look at the plug that came out of there. Just cut it like that much and then break it off for two reasons. One, it can, you don't want to just fall on the ground. And two, it can pinch the saw blade and All right, that's not going anywhere, especially since the rock is pushing this way. All right, let's figure out our angle here that we're gonna cut this beam at. This is representing the top. So if we're coming from there, this would be the top, which is the long end. All right, this is our template. There. Hey, look up. Look up. All right, just hold it. Hold it right there. All right, that's our cut right there. Working, but let me try the plasma cutter. Look at Cody up there. Hey, Cody. What do you, he keeps going up the spiral staircase. He likes going up it, but he's afraid to go down it. And they get stuck up on the roof. Needs to go. It's about where it needs to be. It's just got to get twisted and go up a little bit. All right, I got about a foot of weld on that, so that's not going anywhere. Let's get this pinned into the ground now. This is a 1-inch rebar. All right, I got some epoxy because that's more for like a pulling effect, but why not? All right, so I got a bunch of pieces of 1-inch rebar drilled into the ground, epoxied into the ground, under the I-beam welded together, and yeah, that's not gonna slide anywhere, that beam, because if it was gonna do something, it would go that way. But that's what those are preventing. Plus, it'd have to push this whole building, which the building is heavier than this rock. All right, let's get the form made and get this concrete poured. Hey, Cody. All good to pour? Yes. All right, so concrete can definitely be poured in the wintertime, but there's a few things you gotta do differently. You know, one big thing here is I don't want to pour concrete on top of ice, so let's melt that out of there. my camera? Crap. I was carrying this thing, hearing this fire burning, and this tripod was like burning with this invisible fire. Man, that was crazy. This is hot water. Like I got the 5,500 PSI stuff. That's strong concrete right there. Alright, there's 8 80-pound bags in this thing. All right, we're going for 9 bags this time. One more mix. Let's let that get a little harder, cover it up, then let it get hard for days. And we can pull that log out of there and put up the second I-beam. All right, so here we are, actually a few weeks later. I got my lab inspectors here to inspect the concrete. If Cody would take his job serious. Cody! All right, Levi, check it out. All right, so they're checking it out now. It all looks good. All right, so I did have this covered, but it's been pretty warm out. But I even had like insulation and stuff on it for like a week. inches more than this board. That's the way to cut a beam like that. Use the circular saw and then the plasma cutter on the web. Make sure you scrape this stuff off because you can't weld through that. But it comes, see, it comes right off. This. I think I need to dig that out of there. 5 inches down from where I want to be right there. And then 10. So if I add 15 inches, I've been ignoring this loose belt. Look how loose that belt. I can't see it. How loose that belt is there. I got it. I'm gonna weld the top and then I'm gonna cut that lower. cleaning this right down to the bedrock so the concrete kind of sticks to the ground better. All right, I'm good with that. That's that long now. All right, that's pretty much empty. That just needs to be rinsed out. All right, we're up on the 4th floor here. The plan is to just grout these precast panels together. I was saving that for doing these blocks, but since I have a little extra concrete, this stuff falling in these. It'll be cold out tonight. I mean, not that cold, like mid-20s. All right, that's all that takes to protect that from freezing. It's going to be mid-20s. That's not even that bad, especially for a big cube of concrete like that. Pull the cover off of this. This thing, it's so hot. I mean, not hot, but definitely, the cold definitely didn't affect that. All right, that took 15 minutes there. That's not bad. So I just gotta do that 3 more times. Noticing what I think was the weak link here. So if this rock ever did move, what could happen is this plate could have went up, sheared these bolts off, and maybe, you know, then maybe the rock could have slid under the beam, maybe. Now with that there, see how the rock starts kicking out naturally? That will prevent that from going up. And that added, I say that added a considerable amount of strength right there. All right, I got that all welded in there. Plus, it's all compressive load anyway, so. All right, since these are probably gonna be here for hundreds of years, sign my name and date. One more thing I want to add to this one. My engineer consultant was saying that my bolts here are now the weak link for shear, which, you know, it's probably fine because it's like, you know, most of the force is going this way into this plate, but it's real easy to just add something right here. Like, put it right like that. Good with that. There's no way that's gonna shear off of there now. One more thing I want to do to this. This is that adhesive 2-part stuff for concrete and steel. Anywhere where there's a little gap. I put this in the toaster oven too. These things are so much easier to pump when they're warm. I had it like 200 degrees for 15 minutes. You know, you don't want to cook it or melt it. the way this stuff works, it's a two-part product. Anything two-part is usually a lot stronger. And it mixes in this nozzle. All right, well, that stuff will definitely help. I'll finish that up. And I'll put links in the description for all the tools I used in this video. I did use some interesting stuff like that mag drill and the circular saw and even that cement mixer. You know, having a mixer like that is great because like a pour like this was 29 bags in that one and 20 something in that one. See, that's too small to order a truck. And to do that by hand, yeah, that's doable, but it's not very fun. Skid steer mixer just kind of takes labor out of small concrete pours like this. So look who I got today. I got Sadie. And I got Lacey. And Cody and Levi are somewhere. All right, Sadie's doing the inspection. Come on. Cody, you want to help do the inspection? All right, well, I'm calling that finished. Oh, I feel a lot better about this rock now. I was kind of, you know, I was ignoring it for 4 years and all of a sudden it was like a problem. So, you know, the thing probably would have been fine, but I definitely feel a lot better about this. So, all right, I'm going to paint this too. But I'm about to paint this entire building. Needs paint because I just put a big addition on the top of it, which is all bare steel. All right, so I did actually consult with an engineer on this project. I mean, first I went into it just kind of guessing, like, well, I got a big rock that I don't want it to go this way, so let's put some giant beams up against it. And I just kind of picked the biggest, cheapest beams I could find. I got a good deal on these. But then consulting with the engineer, kind of my questions were, I was just curious on sizing of the beams. So I'll go over what I did to determine that this was going to work. So the first thing was just kind of, I figured, all right, well, if the rock weighs this amount of weight, the beams should be, in theory, able to hold that much weight up. Even though they're not actually holding up the rock, they're just keeping it where it is. But, all right, so let's go through, let's measure this rock. It was 16 right there. We'll just call it 18. 9 feet right there. All right, now this last measurement is the one that's harder to figure out because you can't see most of it. Now, what we can see here, I mean, we'll call that, I mean, it was just shy of 7 feet. As the rock goes that direction, I think it's growing out bigger. So, but the more it's going into the cliff, the stronger it actually is because that's actually what is holding it up. All right, so now with these measurements, we can estimate the weight of the rock. All right, so here's some notes I got back from the engineer regarding how strong the beams were. So we have two W18 by 76 I-beams. One is 9 foot and the other one is 12 foot. And we got a safe and a max load that they can carry, and it's rated in kips. So the max here we're seeing is 1,500. So as far as the weight of the rock, so the rock, we measured it at 18 by 9 by 7. So that is 1,134 square feet times 170 pounds per square foot equals this, then divided by 2,000, we get just under 100 tons. 100 tons, then we use the calculator to figure out how many tons is in a kip. Put 100 ton in as 224 kip. So our rock is 224 kip. Our two beams had a max at 1,500. All right, well, based on those calculations, these beams should be more than strong enough to hold up this entire thing. So I feel good about this.